In this video, I want to solve some problem from fixed point and Newton method. Let me start with a very simple example. Let me write the problem. Let x be equal to square 2 plus square 2 plus square 2 and so on. Something like this. We can find x easily by, in fact, a second order equation. But we want to solve this problem by fixed point method. So, find x by fixed point method. Now, let me start to solve the problem. First of all, we have x equal to 2 square root plus square root of 2 plus square root of 2 and so on. Okay? This get x squared equal to 2 plus square root of 2 plus square root of 2 plus square root of 2 and so on. Okay? But we know that this is equal to x. So we can get x2 minus x minus 2 equal to 0. We can find x easily by the delta technique for second order equation. So we can get x equal to plus 1 plus minus square root of 1 plus 8 over 2, and this gives x1 equal to 2 and x2 equal to minus 2. This is not acceptable and this is okay. But I want to find is x1 equal to 2 by fixed point method. To this end, we have to find a function g of x based on the equation, based on this equation. Call this equation f of x. Let f of x equal to x2 minus x minus 2 equal to 0. So, if we compute f1, it will be 1 minus 1 minus 2. This is minus 2 and this is negative. And if we compute f3, it's 9 minus 3 minus 2. It will be 4. This is positive. So, there exists a c between 1 and 3, okay, such that f of c equal to 0. Now, if I want to use the fixed point method, I have to construct a sequence xn plus 1 equal to g of xn. But the question is, what is g of x and how can I find g of x? Let consider x2 minus x minus 2 equal to 0 and we get x squared, so we equal to 2 plus x, and this gives x equal to square root of x plus 2. Now, we define this one as g of x. G of x should have two property. Okay? Property number 1. It should have this property. G of 1 and 3 is subset of 1 and 3. This is clearly true. Why? Because square root of x plus 2 for all x between 1 and 3 are in the closed interval 1 and 3. So this is true and it need not to check nothing. But property number 2. Compute g prime of x. G prime of x is equal to 1 over 2 square root x plus 2, and we know this is less or equal to 1 over 2 1 plus 2 square root. Okay, so this is 1 over 2 square root of 3. This is less or less than 1. This is true for all x between 1 and 0. Okay, so two properties have satisfied. So we can define xn plus 1 equal to g of xn equal to square root xn plus 2. And if we start by, for example, x0 equal to 1.5, we can find the root by fixed point method. Let me show you in the MATLAB code. I showed you before, this is the code of fixed point method. Now, if we define g of xn something like this one, square root of x plus 2, and I start, for example, with 1.5, something between 1 and 3, and I run the program, I can find the solution in 11 iteration and it converges to 2. And in fact, this function that I found here works for the fixed point method. This is the first example. That was a very, very simple example. Let me solve another problem. The other one is example number 2. Let me write the problem. Consider the equation f of x equal to e to power of minus x minus cosine of x equal to 0. I want to think, determine number of roots of f of x equal to 0 by MATLAB, and the second one, find the first positive root of the equation by fixed point and Newton method. Okay, let me solve the problem. The first part. Okay, first of all, let me find number of the roots by MATLAB. To this end, you have to run your MATLAB program or Octave. There is no difference, almost they are same. And you have to plot two functions. Let me show you here. First of all, you have to consider two different functions and plot both functions in the same, the Cartesian axis. Let me show you. Yeah, I'm here. Now, consider the first one, for example, e minus x minus cosine of x equal to 0. This gives e minus x equal to cosine of x. Now, consider this one as y1 and this one as y2. So, in fact, we have to plot y1 equal to e to power of minus x and y2 equal to cosine of x in fact arbitrary interval, for example in interval -1 to 5. Okay, when we plot these two functions in the same coordinate, in fact the intersection of the curves are the number of roots. Let me show you here. First of all, you consider x equal to -1 with step 0.01 to 5, and consider y1 equal to exponential of minus x, and the other one y2 is equal to cosine of x. Okay, now you plot both in the same figure, x and y1 and x and y2. Okay, now we have 1 0 here, the other one here, and the other one here. This is 0, we know this is 0 because e to power of minus x minus cosine of x for x equal to 0 is 0. So this is the trivial root, and the other roots, one is between 1 and 2, this one, and the other one, this one, is between 4 and 5. Okay, now let me try to find the roots by in fact both method fixed point and Newton method. Okay, for the in fact fixed point method, consider f of x equal to e to power of minus x minus cosine of x. So f of 1 is e to power of -1 minus cosine of 1, this is minus 0.17, and this is negative. And f of 2 is e to power of -2 minus cosine of 2, and this is 0.55, this is greater than 0. So there exists c in interval 1 and 2 such that f of c equal to 0. The main theorem of the fixed point method, the intermediate value theorem, guarantee the existence of the solution. Now, we have to find xn plus 1 equal to g of xn, and we have to find g of x from f of x. Okay, we have two different type of g in this end. Okay, so you consider f of x equal to e to power of minus x minus cosine of x equal to 0, and this gives e to power of minus x equal to cosine of x, and this gives x equal to minus ln cosine of x. But I say the second property for this function in interval 1 and 2 has not satisfied. Why? Because if you consider, for example, g of x equal to minus ln cosine of x, and you compute the g prime of x, you will get sine of x over cosine of x, and it will be tangent of x. And for p over 2 in 1 and 2, we get g of p over 2 equal to infinity, and this is not in interval 1 and 2, and this is not less than L less than 1. So this g of x is not okay. But we have another one. We can take arc cosine from the both side, and we get x equal to cosine minus 1 e to power of minus x, and then we define g of x equal to cosine minus 1 e to power of minus x. In this case, we can get g prime of x equal to e to power of minus x over 1 minus e to power of minus 2x, and this is less than equal or L, and less than 1 for all x in interval 1 and 2. So xn plus 1 equal to gxn equal to cosine minus 1 e to power of minus x is a good choice for the fixed point method. Let me show you in the program in MATLAB. First by this g of x. Okay, let me keep it and let me show you here this one. Bookmark this this one and this one. Okay, y equal to a cosine e to power of minus of x, and we choose x1 equal to 1.5. I want to find the root between 1 and 2. So the starting point should be between 0 and 1. For example, 1.5. And if I compute, I run the program, I get the solution in about 12 or 11 iterations. It's okay. Now, let me change the starting point. For example, let me change the starting point from 1.5 to, for example, 4.5. Okay, 4.5. I want to see if the code converge to the another root or not. So let me show you. I choose, for example, 4.5 and run the program. We get, let me try 4.5, save and run. No, something wrong. Let me check. No, in both cases it converges to the first root 1, 2.9. Now, let me show you if I want to use the Newton method, what happened. If I want to use the Newton method, I have to choose another sequence in this form. Xn plus 1 equal to xn minus f of xn over f prime of xn. And it will be xn minus, so f of x is e to power of minus x minus cosine of x. In fact, it should be xn over minus e to power of minus xn plus sine of xn. Now, if I put these two functions in the MATLAB program for the Newton method, here I mean, you can get y something like this and yp something like this. Okay, now let me put 1.5 as the starting point and run the program. We can get the solution, exactly the same solution, the same root, in fact, in just 4 steps. But in fixed point, we get 12 steps. Now, let me change the starting point here. For example, from 1.5 to 4.5, and let me run the program again. You can see in 3 steps, we converge to another root in the interval 5 and 4. In fact, exactly in 4.72193. Okay, so this is 2 very simple example of Newton and fixed point method. I try to solve more problem in the next videos. So please follow my channel and subscribe my channel and introduce my channel to your friends. Thank you.